trying to do is finally, it's been building forever, it seems like, finally taking everything we've done the last few days and putting it all together in our unit circle. So what we are going to be doing is to find exact and or approximate values for our trig functions at any angle. Okay, this first part is actually going to look kind of similar to what we did last class. So here's the unit circle. This is a circle centered at the origin with a radius of 1. So in each direction, we have a radius of 1. So let's say we have the terminal side of an angle meeting up with that unit circle. This looks exactly like what we did last time. Okay, so we have our unit circle. Its radius is 1. And then the terminal side of an angle is meeting or intersecting with our unit circle. We called that point P. Remind me one more time, we said it earlier. How did we find every x coordinate of that point? Cosine, very good. So when we're on the unit circle, we can just take cosine of that angle. And how did we find the y value? Sine. Okay. So that's when you look at your unit circle and those coordinates, you'll find the cosine of that angle first. You'll find the sine of that angle second. Okay? So our unit circle is a circle centered at the origin with a radius 1. The coordinates of point P, and guys, realize that that point P could be anywhere along that circle. The coordinates of P are cosine of that angle and sine of that angle. Okay, what you see below then is an almost completed unit circle. Like I mentioned to you, the only thing that is not included in this unit circle are the tangent values. Okay, the tangent values. Okay, so in the first example, find the exact value of every trig function. This is just you getting practice using your unit circle. That's all this is. Okay, so if you don't have your personal unit circle all the way complete yet, just use, the one that's there in your notes, okay? So, remember, every x value is what? Cosine. Every y value is sine. So if I'm asking you to find sine of 90 degrees, here's how we'll use our unit circle. You'll go to 90 degrees, which is right here. If I need sine, I know that's the y value, so sine of 90 degrees is 1. Okay, that's all. Cosine of 60 degrees, so 60 degrees is right here. Going to the point, I know cosine is x, so cosine of 60 degrees is 1/2. What about sine of negative 45 degrees? Where would you go on your unit circle?
You would go to the C coordinate.
But which angle would I go to?
The third one in on the, or the second one in on the.
Okay, so for negative 45 degrees, we're looking at 315. And then what?
Why would you go to 315?
Because 315 is the same angle as negative 45 degrees. Negative 45 degrees is just going 45 degrees this direction. That's 315 degrees. They're coterminal.
So what's the difference between that and then the 225? When are we going to use it?
Sine of negative 45 is negative radical 2 over 2. All right, I'm going to give you about 3 minutes to do 4, 5, and 6. Go. All right, pick up. Cosine of negative 30 degrees. What do you have? Radical 3 over 2. Very good. Ellie, what about sine of 360 degrees? 0. Very good. Nick, what about cosine of 180?
-1.
-1. All right, very good. Second page. Sine and cosine are what we call periodic functions. What this means is that the functions have repeating values. The functions have repeating values. How often do the functions sine and cosine repeat? Let me rephrase my question. Not just within one unit circle. I don't know.
360.
Every 360 degrees. That's what I'm looking for. Dang it. Okay, so we said sine of theta and cosine of theta repeat every 360 degrees. 360 degrees is what we call the period. Okay. So let's say you have your 30-degree angle here. If you rotate that angle around another 360 degrees, its terminal side ends up in the same place, right? The sine and cosine values of 390 degrees, which is what you would get if you rotate that around, are the same as 30 degrees. If you rotate it around another time, it's going to be the same, okay? So if you are given something like the first example, find the exact values of sine, cosine, and tangent of a 900-degree angle, what do we need to do? We need to subtract 360 from that until we get what? Until we get basically on 0 to 360. So 90 minus 360 is, I'm not sure what.
540.
540, that's not quite enough, so subtract it back again. 180. So what we'll be doing is going to your unit circle, looking at 180 degrees for the sine, cosine, and tangent. And I can go ahead and say sine of 180 degrees, cosine of 180 degrees, and tangent of 180 degrees. So based off of your unit circle, what is the sine of 180 degrees? 0. And cosine?
-1.
And tangent? 0. Very good. Okay, now we have negative 930. So what are we going to do here? We're going to keep adding 360 until we get back to 0 to 360. Probably have to add it a couple of times. What's negative 930 plus 360?
Negative 570.
And then plus 360 again. Negative what?
210.
Negative 210. All right. Let's add it one more time.
Wait, isn't that a degree?
You could do negative 210, but a lot of people just like to work with the positives. So if you want to keep adding, so you're between 0 and 360. So, oops, not 150, but 360. That's what you get. That's what you get. So, negative 930, this is going to be the same as sine, cosine, tangent of 150. So at this point, you are going to refer to your plate. All right, so sine of 150 is 1/2. Cosine of 150 is negative radical 3 over 2. And then tangent is negative radical 3 over 3.